to also get this thing working. So a few quick notes before we start. The power sources will be in the front in this room and in gallery. The seminar rooms are upstairs. We want to thank our sponsors, so we want to thank Oracle, MySQL, the German Unix Users Group, GUG, Team Mix for doing our Wi-Fi, and the password you will see on the doors for the network here, which is openSUSE. We will be having lunch. There'll be a food truck coming between 12 and 2, so please find some time to go out and get some lunch that's sponsored today by MySQL. So, it's my pleasure to introduce our first keynote speakers. And the first person I want to talk about is Thomas. Thomas is the CTO of SaltStack, and the technical co-founder of Salt. And he is joined today by David Boucha, and David likes to use Salt as a tool to bend technology, I guess is what he had said. And he's going to be joined by Joe Werner from SUSE, and they're going to bring us into the world of automation with Salt. So please welcome them to the stage.
I'm really excited to be able to kind of kick off the openSUSE conference. It's been a lot of fun coming out here, and it's also been a lot of fun to meet a lot of SUSE people. So personally, I only recently switched over to SUSE. For a long time, I was a big Arch Linux fan and used a lot of Red Hat. But last year, when the SUSE team reached out to me and said that they were using Salt for the new SUSE Manager project, I thought to myself, maybe I need to look at SUSE again. And I hadn't looked at SUSE for many, many, many years. And I was very, very surprised at what I found and learned about SUSE, and was instantly convinced that SUSE is hands down the way forward in Linux distributions. Very, very exciting stuff. But what I'm here to talk to you today about is about next generation automation. So let me start by talking about just infrastructures and systems in general. One of the major problems that we're running into right now inside of infrastructure deployments and development is the increasing complexity and diversity of infrastructure environments. So we have more tools than ever, more models than ever for deploying and managing infrastructure, but we also have more things than ever, all the way up to Internet of Things and devices that are implanted all over the place. We've got all these new hyper-converged data center and hardware plays, as well as hybrid cloud, et cetera, et cetera. And so what we're seeing is something which we all should definitely have expected. And that is the dramatic increase in the complexity of our information systems. Now, as we increase the complexity and the coverage of these information systems, the question arises and says, how do we deal with this new and more increasingly complex environment? And this is where the model of automation that we use inside of SaltStack comes into play. And the model of automation that we use is one that is made to span all of these different areas, normalize the access that we have across a vast array of devices, and making it very, very easy to automate increasingly large and complex environments in a very, very smooth and manageable way. So, the first thing that I want to talk about, therefore, is complexity. When we are setting up these systems, we have seen, and especially over the last five to 10 years, a dramatic increase in the complexity of the infrastructures that we're interfacing with. And so I think one of the questions that we have is, where is the dramatic increase in complexity coming from? And I would say that it's coming from our increased availability of automation. As we have more automation that is available, it gives us more free time to make things more complex and more terrible, but at the same time get more stuff done. One thing that we see a lot of, and one of my favorite examples, is that we go into an organization and they say, well, before we introduced a DevOps and configuration management models, we were deploying 5 apps with a team of 5 people. And now we introduced these new automation models, we're deploying 50 apps with a team of 5 people. So if automation breeds more complexity and allows us to get more done and expose more functionality, then what does that mean? Does it mean that we're moving towards a scenario where we apex on the complexity that can be handled in an infrastructure? Or are we moving towards a scenario where we need to come up with new models of automation? Okay. The next thing that I want to talk about before diving into models of automation has to do with what it means for an infrastructure to be large or complex, or for a problem set to be complex. Back at SaltConf a few months ago, I was asked, what does large mean to you? And I explained that some of the largest infrastructures I've seen are only a few hundred servers because of the incredible level of complexity inside of the applications that are deployed. And then when we see very, very large deployments of tens of thousands and even millions of servers, oftentimes they have a fairly heterogeneous use case across those servers. And so I would say that something that is still small physically can still be large in its complexity. Now, how do we handle this? How do we handle increased complexity and larger environments? So it's not a bad thing that things are more complex. It's a bad thing if we cannot adequately manage those complex environments. So one of the things that I go around and say is that I don't believe in revolution, I believe in evolution. I believe that when we develop new ideas, they are developed on top of older ideas, and that they therefore grow. And that it's very difficult to bring in entirely fresh ideas and impose them on an existing infrastructure or culture. Now, what does that mean then when it comes to infrastructure automation? If we look at the popular ideas around infrastructure automation that have emerged in the last few years, many of them stem back to 2 core ideas or concepts. One of which that I want to talk about first is something that was described in some academic papers in 1993 by a man named Mark Burgess, a brilliant man and the man who created a piece of software called CF Engine. He defined basically the concept behind what we now call modern configuration management. This is the idea of taking what a system is and abstracting what that system is in a declarative fashion, so that you can declare what state the system should be in, and then apply it again declaratively. This is the aspect of Salt, for instance, in which we're the most well known for. But as I developed Salt, we were certainly not the first ones to develop this concept. And so I realized that there are more vectors needed for automation. And the first thing that I did was look at other automation systems which exist and realize that we need not only to control the finite declarative state of systems, but we also need real-time access to those systems. The ability to reach out to those systems, change things on the fly, query those systems on the fly, and apply stateful changes on the fly. And so this is where I then go in and look at orchestration and remote execution models. Orchestration and remote execution models come back and focus around a number of their own philosophies. The main focus I decided to use with SALT's remote execution was to just say, I need to make it as fast as possible. If it's as fast as possible and can reach all of my systems in microseconds, then things like building linear orchestration models is easy. Linear orchestration or runbook orchestration is, again, something you're probably all extremely familiar with, where you've got a task which runs in sequence. So some of the problems that we run into, though, with linear orchestration at scale is that it can take a long time to run. And those linear orchestration systems are generally also not idempotent and declarative in the way in which they apply changes. They're very dependent upon step 1, then step 2, then step 3, etc., which breaks that core model, which was described again by Mark Burgess originally around having a declarative system. And so we started to say, well, can we do better than this? Can we figure out a way that's better than our classical linear orchestration model? And so I thought, if everything is evolution, then maybe we need to evolve out of experience from areas that aren't just in IT automation. And so I thought back to my experience working with the US government and some time I had spent with US naval submarine automation. When we look at robotics automation, it functions very differently than what we're used to inside of IT. Much of the robotics automation that we see has to do with the definition of a finite rule set, which declares that if scenarios occur, then react to them in specific ways, and then applying that finite rule set onto the actual automation platform. And so there was a model inside of robotics that I became very fond of called flow programming, which allows us to do just that thing. Say, based on the information that's coming back from our sensors, and based on what information it is that we are aggregating from those sensors and from those events, what we're able to do is define when we're going to act, okay? And so I asked myself, could this model be used for systems automation, okay? And so once I brought these concepts together is where the definition of SALT's automation platform really became cohesive. When we describe what SALT is as an automation platform, it's primarily 4 things. We have the remote execution platform, which I talked about first. We've got the configuration automation system, which is, again, what people are most familiar with. The whole DevOps declare your infrastructure approach. We have extensive cloud control, which I'm kind of glossing over in this talk. And then we've got the event-driven orchestration. Now, the event-driven orchestration is something which is a lot more unique to how SALT handles orchestration and automation. And so let me start by actually describing, for those of you who are not as familiar with SALT, some of the basics with respect to how it works. So SALT can operate, as you can see, in an agentless or agentful way. We install an agent, which we call a minion, out on all of the systems that we want to manage. If we have a system that we cannot install an agent on, then we use one of the agentless pipelines, which is either the proxy minion or SALT SSH. And by cannot or don't want to, it doesn't matter. We're cool anyway about it. And then that agent is where all of the intelligence sits. One of the problems that we run into with dealing with distributed automation is that we have to consider the fact that we need to have, well, distributed intelligence and distributed work happening. Some of the problems we run into with a lot of automation platforms is that they still centralize the majority of the work, which also causes scaling issues. But if we distribute the work, the logic, and the intelligence, out to the machines which are actually being automated, then that can, again, substantially improve our ability to scale. And so all of the information, all of the intelligence about how to do the automation work exists in these minions. The minions are then continuously connected back up to a Salt master or a master cluster. And then that master, the work it does is limited to the coordination of those minions, which again assists us in scaling out to very large scale. And why we have deployments of Salt, which are as small as 5 to 10 systems, but as large as our largest installation right now is actually getting close to 1 million Salt minions. Now, when we look at how this works, the next challenge that we run into is network topology. Again, a lot of automation systems mandate that you either need to have bidirectional communication over the network to be able to manage the end nodes, or that your central point reaches out to the nodes that you're trying to manage. Salt's approach is to make sure that we have the maximum level of topological flexibility. And so the way that we do this is that the controlling master doesn't need to be aware of where any of its minions are. They just need to be aware of the master. And it doesn't need to be able to route to the minions. The minion only needs to be able to route to the master. And again, this substantially simplifies the topological constraints. Okay. So if I start there at the bottom with remote execution, and we'll demonstrate all these things in just a few minutes. When I start at the bottom with remote execution, what we're looking at is that the Salt master is able to send in parallel to all of these continual TCP connections, which are connected concurrently to the master, is able to send in parallel a tiny packet which tells the minion what to do. Since the minion has all the intelligence in and of itself, we can dramatically minimize the amount of information which needs to be sent over the wire. And this is also very important when it comes to dealing with scale, okay? And then those minions can execute based on the remote execution pattern which they receive. Next, when it comes to configuration automation, we're able to declaratively define on the master end exactly what needs to happen to those minions or the declared state in which they need to be. And then we can use the remote execution bus to tell them when to apply those states, which again allows us to have an instant connection and an instant modification of those systems. Okay. And then the hallmark here, and kind of the point of the talk I'm trying to give, is around the event-driven automation systems. So like I was saying with robotics controls, there is a model around making an event-driven automation system. And that model is that we need to be able to get events or alerts from all of our controlling systems. So how do we do that? But not only do we need to get those events need to be processed. And once those events are processed, the system processing it needs to be able to enact real change and real management on those subsequent systems. And so this is where the concept of event-driven automation comes into play. So that means that we need to act whenever a system is ready. The defined rule set that we're dealing with needs to be capable of being declarative, okay? And we need to converge on these concepts of monitoring and management. And so on all of the minions that we have inside of Salt, there's a system called beacons and the Salt event bus. Everything that Salt does gets converted into an event. And the beacon system inside of Salt allows us to absorb events from anything that is happening on that system and maintains itself being extremely open-ended. So instead of saying I'm generating events for a very specific automation purpose, we're able to say I'm generating events for whatever I want to generate events for, okay? All right. And so then if we look at this event-driven automation, it needs a number of building blocks. And those building blocks are very much so those cornerstone components of what SALT is. So we need open-ended remote execution so that we've got the ability to control the remote systems that we need to react to and manipulate. We need the idempotent or convergence routines that exist inside of configuration management so that reapplication of certain routines doesn't modify the system in bad ways. Event generation is important. I just mentioned that with respect to SALT's beacon system, but also deep integration. We need to be able to talk to virtually any type of system that's out there. One of the demonstrations that was done last year at SUSECon was using SALT to integrate with and control light bulbs. And the demonstration we're going to do today has SALT integrating with text messaging using the Twilio APIs, okay? And so that deep integration is important because the automation systems need to read from and manipulate diverse sets of systems and converge on decisions between diverse sets of systems. So that what is happening with respect to a thermal gauge can be used to define potentially how server equipment is operating, and likewise with storage and networking and converging those concepts together. All right, so the way in which this is accomplished is through a concept called a reactor. And so we have all of these events that are being generated, and they are then ingested back into this reactor system that exists on the SALT master, okay? Now, in SALT, we have defined two types of reactors. There is the single event reactor. The idea here is that it waits for a very specific event to come in, and then it reacts to that specific event. The benefits here is that it's a very simple reactor. It's very high performance. It's very easy to understand, very easy to learn. Now, and it makes a lot of the simple use cases of event-driven automation also very, very simple. Now, the other type of reactor which we define is an aggregate event reactor. Now, an aggregate event reactor is more complicated and a little more complicated to understand, but allows you to define substantially more complex rule sets. So inside of SALT, these are expressed through these two reactors. The original SALT reactor, which we introduced in 2013, and is extremely hardened, used the world round, is used to manage reactions and events spanning, again, tens of thousands of servers. So very, very hardened. And then a brand new reactor, which is the aggregate reactor. I spent a little over a year and a half doing research trying to figure out how to build this, that we very recently introduced, albeit it's still experimental, called the thorium reactor. And this exposes this flow programming paradigm to event-driven reactions. Even in the demo that we're doing today, we're still going to be using the single event reactor just because thorium is so incredibly new. But the benefits or the things that we're excited about with thorium have to do with the fact that it is made to be able to aggregate large numbers of events and make extremely intelligent decisions about what to react to. Some of the other things that's really interesting about thorium is that it's an event reactor system which is actually built on SALT's configuration management engine. So it accomplishes the idempotent and linear scheduling tasks that it does because it takes advantage of the existing SALT configuration management engine, which is in and of itself extremely hardened and widely used. Okay. And so then this brings together this idea or this model of event-driven automation. With event-driven automation, we don't have to wait for linear orchestration to pan out across large sets of servers. We don't have to stop linear orchestrations over and over again because we can have item-potent routines happening inside of those events. And it also allows us, again, to converge on a vast array of individual components so that, again, we can take information from anything or any type of system which could be communicated with and then converge that information into a single decision-making matrix, so that all of those integrations come together. All right. So I'm going to mention a couple of use cases, then I'm going to ask Dave Boucha to come up, and he's going to give us a demonstration. But a couple of the use cases that we've got here is some of our larger installations is LinkedIn. LinkedIn has been using the event-driven automation platform system for quite a few years now, to automate code rollouts, to automate continuous integration and continuous deployment integrations. And LinkedIn has also been using it for the filtering and management of incoming data, so that all of the information that's happening in their data center is filtered using the reactor system. And then Intuit, which is actually Intuit's a very American company. They do American tax processing, so you probably haven't heard of them. But so they're a very, very large organization in the U.S. And similarly, they are using event-driven automation to deploy multiple stage automation, as well as continuous integration, continuous deployment. And we've got hundreds and arguably thousands of infrastructures making heavy use of the SALT reactor today. Let's see. And so again, this is a model which diverges from the traditional models of orchestration and automation. It's a model that allows us to be substantially more scalable, allows us to function in a faster way, and allows us to have a level of convergence and distributed logic which otherwise we can't really attain using a lot of the traditional methodologies. Okay, so Dave is going to give us a fantastic demonstration, which I promise works. So, here you go, Dave.
Okay, really excited to be here. So this is where the rubber hits the road. We're going to do some live. This is not a canned demo. I tested it this morning in my hotel room. It worked great. Got here, it was broken. And I realized, it was our networking issue, so we're good now, supposedly. So when I first found out about SALT, I was at a Python user group in Utah, and I met Tom, and he was talking about this new project he was building out to manage infrastructure, and it sounded really exciting. And so I got involved helping port the SALT minion to Windows, fixing bugs. I was like, in the original IRC channel, I think I was like the third person to join or something like that. So I've seen SALT kind of go from the very early stages to where it is now. And one of the things that got me most excited about SALT was the immediacy of interacting with your servers. Now, instead of running a report and getting a report a few minutes later, or manually logging into a bunch of servers and checking disk space and all that stuff, I could do that from one machine, get all that data, and then do what I want with that. So right here we have a SALT master with several minions. So we're going to run a little command here that will tell us, okay, so I have 4 minions here. I have a CentOS 6, SUSE 13.2, and a trusty, Ubuntu trusty server. And what I just ran there was called an execution module. So there's actually a test.py, if you're familiar with Python, and there's a ping function in there that just returns true. SALT ships with a whole huge library of these execution modules that do everything from manage file systems, managing your databases, installing, configuring software, managing your Ruby installation. To, I mean, just sky's the limit. Docker, LXC, just all kinds of things that that you can use. This test module has several things we can do. Like I can see what version of Salt they're all running. So you can see here. How's the size? Can everybody see that okay? Okay. So you can see, all the versions of Salt they're running. One thing that's fantastic is we have a concept of an outputter, so we can change our view. So here we have a kind of a human readable view, but if I want to get that in JSON so I can use that in some other application, I can say, hey, I want this in JSON, then I can pipe that to another application or to a file to be used elsewhere. It's really handy. So we have some other functions like we have a package module where we can do, for example, list packages. So there's every piece of software on all 4 of those servers and the version that they have. So if you need to make sure you have a certain version of software, I can check what that is right now. I don't have to check a database or a spreadsheet or assume we should have a certain version. I can check and see what's out there right this moment. There's a disk usage here. There's all of the status of all the file systems on all my servers, so I can check what their current status is right at this moment. There's a whole ton of things. Now if you notice, we have 3 different operating systems we're running as, I run that command as. So disk.usage is cross-platform. That'll work on Windows, OS X, all the Linuxes you can imagine, even some of the older Unices and things like that. So it's really powerful in that way. It's very cross-platform, including things like installing packages. So so here I'm going to see what our OSs are. So we have 2 Ubuntu servers, openSUSE and CentOS. So I can do for example, okay. So if I have I can install Apache 2 on my Ubuntu server. This will come back and tell me exactly what packages were installed. And there we go. So now Apache is installed on that server. And if we use the network module, I can get the IP address of that server. And there's the default Apache web page there. So again, this is all live. We are doing things really, quickly, and I can remove that as well. Okay, so that's an execution module. Now, we may not want to do everything like this live on a command line. Humans are, obviously notorious for. So now you see that Apache is no longer serving there. So we have a thing called a salt state that allows us to statefully determine what should be installed or how we're going to manage our servers. So if we go to our default location for our salt states, I'm going to create a new salt state that will install Apache. So we're going to put our package name. I got installed. Now this is a stateful way of managing it. So let's say I had the wrong package name. Oh, let's see. So let's. Okay, so now I'm going to run this Apache simple, and it's going to come back with an error saying that unable to locate the package Apache 2.3. So I'm going to come in here, remove this, and I'm going to run this in test mode. Salt's going to go out and say, okay, the following packages would have been installed. Apache 2 would have been installed for us. So let's go ahead and run that. Okay, so that worked. So again, it's a really simple, Apache 2 is installed. You can complicate things a little bit. So for example, in the example I have here, we're going to manage the package and the things in the, we have two variables there. We're going to get the package name. So this makes this state cross-platform. So we can actually tell us that if we're on Ubuntu, we're going to use Apache 2. If we're on a Red Hat-based system, we use HTTPD. And you can determine, you can specify for each OS what the package name should be. We're also going to manage the Apache service as well with this state. So again, this is stateful. If the state is already there, or if the package is already there, Salt will not do anything. So if I run this state again, Salt checked, and it said, oh, the package has already been installed. We're not going to do anything at this point. So that way, you're not going to modify anything unless it's absolutely necessary. Okay, so again, this is an example of an execution module. The text file that we just saw was an example of a salt state. And this is kind of the typical way you would manage your servers, with the master, with your minions. We could also do this over SSH, and also you could also do this without a master at all. Everything can happen locally just on a minion. All right, so now that we have this really fast control over all of our servers, there's some really interesting things we can do with that. So, again, here you can see that running this command, took less than a second on 4 servers. On 5,000 servers, it would take a few seconds, and mostly that's displaying all of the return data on your screen in your terminal. And so we have this really fast communication between our servers and our minions, so you can do things with that connection. So Tom mentioned beacons. So beacons is a little process that runs on your minion on a server that watches something. So we have beacons that'll watch, they'll use iNotify to watch a file or a directory for changes or additions of files. We have a service beacon that'll watch daemons that are running. We have daemons that'll watch SSH logins. There's a whole variety of them. You can watch output of PS, a whole variety of things. And when that beacon notices a change of some type, then it'll send an event on Salt's event bus. So between the minions and the master, there's an event bus where events get sent up to the master. And it's kind of dumb in that it doesn't, doesn't have a lot of intelligence. It just sees it watches whatever you're telling it to watch, and then sends an event. Then on the master or on the minion, you can have a thing called a reactor that will watch that event bus, and when it sees a specific event that you care about, it will do something. And that something could be anything that Salt can do. So if you see an event that maybe your CPU usage passes a certain threshold, then maybe that means we need to spin up another VM or two and add that to the load balancer. Or maybe we need to restart some services, or maybe send a notification to some notification service. It could be, really anything, sky's the limit, anything Salt can do. Salt has a REST API as well that allows you to set up authentication for a user to send REST commands to either execute Salt commands or pull data from that. As part of that, there is you can actually stream that the event stream that's coming through and do something with that. So the demo I have today, we're going to show two different beacons. One beacon is the iNotify beacon, so we're going to watch a directory and a file. And also, we're going to use the Twilio text message beacon to watch an event bus, a message queue on Twilio. So let's look what that configuration looks like. Okay, so here's our beacons section. We have an iNotify beacon. We're going to look for all messages or changes to this /serve/blod.txt. Then we're going to look for, we're going to mask off these close right items for the directory of /serve/testing. And we're going to do this recursively. We're also going to set up our Twilio account information. So we need our account SID and an authentication token here, and then our number, and then the interval that we're going to poll for that queue. If I okay, so now in this top terminal, we're going to watch the event bus. And down here, if so you can see the event bus received an event saying there was a file that had a change of enclose right, and here's the path to that text file. Okay, so here is a web page that's actually being, it's a single page JavaScript application that the Salt API is actually hosting for me locally. And what it's doing is, in the background, it's listening to that event bus. And whenever it sees, it's going to filter through. Whenever it sees an event that matches some criteria that I've set, then it is going to output information about that event to our web page here. So you can see when I modify these text fields, we're just getting these events, and then we're displaying these on this application. So, so that's the again the iNotify. I'm just going to see those there. Now for the Twilio one, we have a phone number here, and if you can keep it G-rated, please. I guess that G-rated is probably a US thing, so keep it suitable for children, please. You can send a text to this phone number here in the US. And every 5 seconds, that beacon is checking that text message queue and then sending an event on the event bus. And then the Salt API is watching that event bus and outputting the things there. This will also do MMS picture messaging as well. Let's see if this will go through. Thank you. Somebody has sent that. So this is kind of a ridiculous thing. You wouldn't do this exact thing in production. But I put this demo together because, to me, it kind of shows you that you can build what you need with Salt. Salt gives you a whole bunch of tools that you can put together to build exactly what you need. Salt tries very hard not to force you to modify your infrastructure to work just like Salt needs you. Salt tries to do things in the way that you need them to happen, because everybody has their own unique infrastructures, and this allows you to build exactly what you need, like I said. So again, this is a combination of beacons, Salt's event bus, and also Salt's REST API here. Please don't send any JavaScript. I'm not sure if this is all sanitized really well, so that could be bad. So I sent the picture text, but apparently it's taking a while to go through. But SUSE paid us extra to have these little advertisements they're sending up here. So okay. So you can see here in this output here, you can see this is the all the events coming through. Again, this is all just data that's coming across this event bus, and you can do whatever you want with this. So using these beacons, we've people have done some really interesting things. So we had somebody have this application they'd purchased from some private vendor, and there's no database involved with this. But they had this application that would just chew up RAM. And over the course of a week, roughly once a week, they had to actually go and restart this cluster of services. And the vendor knew about the problem, and it was just going to be months before it was fixed. So they were able to set up a beacon that would watch the RAM usage of this service. And once it reached a certain threshold, the beacon would send an event up to Salt Master saying, hey, we've passed this threshold. And then the Salt Master knew, okay, when this happens, first we're going to send a notification to our logging server and to our notification server so humans know about this. And then we're going to go through this cluster of servers and one by one restart this specific service to get rid of this service there. So anyway, these are some very powerful tools that Salt will allow you to make your infrastructure just sing and work really well. So I think now we're going to pass on the time to Tom and Joe.
Okay, yeah, now we'll pass the torch over to somebody that many of you already know and love, and that's Joe Werner. Thanks.
Yeah. Good morning also on my part. We've got a pretty good preparation now for arguments why to use Salt. Actually, about a year and a half ago, so the SUSE Manager team, so the team behind our SUSE systems management solution, had that same problem. So we were trying to figure out what is the right tool for our purposes, because we ran into all the problems that Thomas mentioned. Linear execution takes a lot of time. Lots of systems have to be reached, and our existing stack that is kind of 15 years old based on the Spacewalk project does a lot of those things in sequence, and it may take some time. It's not really instantaneous, so it's more of a batch processing. You reach out to the system may come back an hour later or whenever it wants, because it would just wake up every couple of minutes, hours, days, whatever. Yeah, so we were looking for something more instantaneous, better scale, and so on. That's when we decided to look into lots of different systems, and the decision was made to go with Salt for the reasons that Thomas has mentioned. if you're not familiar with SUSE Manager because it's not maybe what you're using as an openSUSE user, just very briefly, we are trying to basically cover the whole life cycle of running operating systems and applications in data centers. I'm calling this the SUSE Manager magic wheel. So the inner part of that wheel, that inner circle around the hub of SUSE Manager is about all the processes from asset management to provisioning, patching software, configuration management, of course, and so on. And the outer circle is kind of the control and monitoring circle. And as you've heard again, Salt can do both. So Salt can help with all those tasks, executing stuff on machines, keeping state, but it can also help a lot with keeping track of what's going on, monitoring things in real time, and then combining those two things, basically acting on those events. Yeah, I like this one, I had to bring it up. That's how marketing kind of sums up what SUSE Manager can do, tame your IT, yeah. Someone mentioned that, yeah, you shouldn't probably use those thingies after the hedgehog has used them. But yeah. So with SUSE Manager 3, the SUSE Manager server basically becomes a Salt master. So all the communication to the managed systems is using that Salt message bus that we saw on Tom's slides. And we also, of course, leverage the event mechanism to collect data back from those systems. This helped us solve quite a few challenges. First of all, better scale. That one I always try to pronounce parallelize. Terrible word for me. We wanted to be able to do things in parallel, at least for hundreds of systems, so we don't have batches of one, but can reach out to 500 at a time and so on, in a very short window of time. We have customers running in the thousands of systems behind SUSE Manager, and they have patch windows of maybe 4 hours per month or per quarter, and everything has to be done within those 4 hours. So that was one of the challenges. And then be expressive. Again, going from this approach where you basically write scripts in a more modern way to an approach where you declare how a system should look like. So go from install this user to this user should be installed. Always check whether it's still there. If not, bring it back. One of the first things we did was to bridge the gap between SUSE Manager's core engine that's mainly written in Java, which was not our choice, but we ended up with that legacy. And it's not that bad, actually, to the Python-based Salt stack. So one of the first contributions we did, Johannes Renner was the main engineer behind that, was contribute an API connector to the Salt API for Java. This allows us to have a very loose coupling between SUSE Manager and Salt. So in the unlikely event that we don't like it anymore, we could just write a new one for something else and rip and replace it. Of course, that's not going to happen anytime soon. Now, I want to guide you through a few simple steps. This is very similar to the demo that we did at the SaltConf earlier this year, where you can go from a generic just enough operating system image that you register to SUSE Manager, assign it to server groups, and then apply the state. So that the overall system state, that's what SaltStack calls a high state. So you can apply individual rules, but if you want to basically get everything applied that should be applied on that machine, that's the high state. Yeah. First of all, because the connection has to be secured, there's some key exchange involved. And in SUSE Manager, it basically looks like this. So there is a command line tool, of course, for Salt. A minion that comes up sends a key to the master, and then the master can either accept that key, you can even put it like auto accept all the keys. If you know your infrastructure, you know, let's say you have a large high performance computing environment, it's completely closed, the network, you own the network, you can just automate this. But if you want to have control, you can check the fingerprint in the UI or on the command line, and then you can apply, you know, assign those machines, accept those keys that are still pending. And then this will actually, again, use the event mechanism in the back, because once the machine has accepted its key, it will send an event and say, well, I'm here now. And now SUSE Manager will read that on the net, on the API bus and trigger the next step, which is, okay, now get all the hardware data, all the software data of that machine and put it into the SUSE Manager inventory. Now the second step is you want to assign state to those machines. And actually, more or less by accident, we came up with a very powerful pattern here that combines the best of the legacy concepts we already had in the SUSE Manager and the Spacewalk project with Salt's state concept. And I'm calling that, for a lack of better name, the groups and states pattern. So this is how it works. In SUSE Manager, you can create random groups. Those groups are actually more like tags. So it's not like hierarchical groups, and a machine can only be in one group, but you can basically have a group for your web servers, a group for your servers that are in a certain rack or in a certain location, or that are managed by Joe or Tom. Machines that are Red Hat systems or SUSE systems. And then you can basically choose a union or intersection, let's say all the SUSE servers managed by Joe that are web servers and running in Nuremberg. So these groups, that's where we assign states to. So let's say we want a state that does all the stuff that you always have to do in all the web servers in the company. Yeah. So we create that state, just like that little snippet that David showed us, to install the Apache server, configure the Apache server, and we don't assign it to a machine, we assign it to that group. And now we can assign systems to that group. And basically by adding those systems to the group, all we have to do is run the high state command, so basically apply the state, and for all the machines in these groups, they will become web servers, and they will stay web servers as long as we keep running the high state from time to time. That's very powerful because it completely decouples two problems. A user who has no clue about how salt states work can still go into the SUSE Manager UI or use the SUSE Manager API and add a new machine to that group, and it will just work. Now, what also helps with that is that we've created 3 layers in both the configuration side. So where can you define your salt states, your salt configuration, and on the SUSE Manager group side, and so on. So in the salt configuration, first of all, we have configuration that will always come with a SUSE Manager. It's taken for granted. So we have a few like keys that we have to roll out on the machine so that Zipper knows about which RPMs it should be using and so on, the signing keys. You can't change them. You can, but you would change them in a place that is read-only on the file system for use. And then we have auto-generated stuff from SUSE Manager. For example, if you join such a group, we will use Salt's pillar mechanism, which is a secure way of distributing data to your machines, and just inject data from SUSE Manager into those pillars. This is also auto-generated states, for example, when we actually add a new package or remove a package. What we're doing is we create a salt state for that. And then finally, there's user-generated content, and that means that anything you can do with a plain salt master in your own setups, you can just basically copy over to your SUSE Manager. There's your playground. You can add stuff. And these 3 layers allow us to integrate with existing solutions, but at the same time have a lot of control about things that always have to happen because they are SUSE defaults, and things that you do from SUSE Manager. And finally, on on the SUSE Manager side, we can apply states to organizations. That means anybody in the whole organization has to do that. Let's say you have a policy that certain users should never be on those machines, yeah, or a policy that the firewall always has to be on. You can do that for the whole organization, and it will always be applied. And then you've seen the groups, so you can apply state to groups, and this basically doesn't mean that there's a that's a second layer, but that's a whole world of layers, because those groups can overlap. So you can have 5 or 6 groups assigned to the same machine. Yeah, one caveat, we haven't figured out yet what happens if they are called in different orders. So that's where you have to be careful. Those states would have to be written in a way that they can coexist, or that, you know, ordering doesn't matter. But we're working on that part. And finally, you can even override settings on an individual system. So if you have 100 web servers, and there's this one web server that needs to have a different setup. Yeah, maybe it's not running Apache, but it's running Nginx or whatever. Then you can do that just as an overlay. And what this helps with is, if you have a setup like a medium-sized web server setup where you have a load balancer, you have a web server and a media server separately, you can just grow that by creating twins. Yeah, basically you add a new web server to that group, you add a new media server to the other group, and just run the states, and you scale out. Another thing, of course, that you can also do because of the reactor mechanism, and we also did that in the demo in Salt Lake City, is that you can make the load balancer aware of those changes, because the load balancer has to know, oh, there's a new backend available that I can point clients to, new web server backend or a new media server backend. So you can rewrite the load balancer configuration just based on those incoming events. When a machine comes up, it's configured. It will send standard events, but you can also, in your states, fire individual events like inform load balancer, and even pass random information, bit of information that you want, like keywords or so. And that way, the load balancer can automatically be updated without any other out-of-band technology, without any need for using, let's say, pacemaker or other HA mechanisms. Yeah, so there are a few more things that we put into SUSE Manager with regard to the Salt integration. There's more to come. I'm just running you through 2 or 3 of those things. First of all, the command line stuff that David showed us, much of that can also be done from the web UI. So you can use, you know, this syntax using placeholders, asterisks, and so on, to scope only the media service. Like this would trigger all the servers that start with media, and do simple commands. In this case, you'd also get the input, the output nicely formatted in the web UI for all those machines. We haven't tried out what happens if you do that to 10,000 servers yet in the UI, but it will work really nicely for a couple of dozen. For now, this is limited to one particular part of the Salt API where you call bash commands. So this is for running, just basically executing bash commands. We are going to expand that and also make use of the fact that Python allows for introspection, so we can basically, while you type, expose all the options that you have for filling out stuff and so on. And another thing that we did, using the existing state mechanisms, we basically created a simple UI for configuring your packages. This was basically because we had that feature already. We wanted to port it over to the Salt-based mechanisms. In the back, this will just create a state file that says Emacs absent, I think, or yeah, I think it's .absent and vim.present. or installed. Yeah, I'm always mixing that up. Yeah, this is of course, that's a standard setup for all the SUSE servers. No, I'm just kidding. So you can do very simple things with packages, like always make sure that Emacs is removed and always make sure that Vim is installed with the latest version or with a random version. So there are two possibilities there. Yeah, we will dive into more of those things in the sessions during the day. My session is going to focus mostly on how you can hack Salt, how you can extend it, like the things that Tom mentioned around managing light bulbs. I think we will see stuff that's being done in the storage team as well, SUSE Enterprise Storage team, and a few other examples around openStack and VMware as well. Those talks are all happening in the gallery room. I think it's over there. Yeah. And I hope you'll enjoy the day and you'll better understand why we are going with Salt. One final remark to the openSUSE guys. Salt is just a super in a way on openSUSE. So we have the not the 2016 packages yet. We are in the process of updating to the 2016 packages, but the 2015 8.8 I think packages are available on openSUSE, both Leap and Tumbleweed, but just super in. And in my presentation, I also have a slide to show you where you always get our latest development packages that we are using for SUSE Manager upstream development as well. Yeah, thank you. And I think now I'll ask Doug again to the stage for some logistics. And of course, question and answers, Tom, David, or myself. Where are we time-wise?
Test.
Yep, cool.
Any questions?
We have a...
There's a lot of people out there who don't come from a big systems background. They may have maybe 3 or 4 servers. How small can your systems that you run be, and you still get enough benefit to make it worthwhile investing in a tool such as Salt?
So really that depends on what you're doing with those systems. So we definitely see scenarios where people see a lot of benefit and they are using less than 5 systems. But usually that's along the lines of where they need to coordinate things that happen on a regular basis, or those 5 systems that they have are fairly transient, so they need to be set up again on a regular basis. Honestly, if you've got 3 servers that you're going to statically set up, then yeah, you aren't necessarily going to see a lot of that value yet. But it is something that even at that scale, if you plan on getting bigger, it's good to be able to define your systems in a declarative way so that what you have done becomes natively documented and it's something that's easy for you to transfer forward. So yeah, I mean, it's easy to say, hey, I've got 20 plus systems, Salt's going to be a benefit. But yeah, it does get kind of tricky when you're down to really, really small numbers. So sometimes it is, sometimes it isn't.
Coming from big systems background, I usually say 5. Once you've got 5 machines, it's really worth it. That's my personal opinion.
Thanks.
Any other questions?
Let me just add to that. So Richard Brown wrote a really nice blog post a while ago on his kind of private setup where he's using Salt. I mean, sometimes it's really what Tom says about documentation, about being able to just rebuild this. If you, let's say you go to a different provider and it's really just 1 or 2 machines, if you know it's all in my states, you can just roll it out somewhere else. You can replicate it. You can also test it very well. We are also using it in setting up the OpenQA infrastructure. It's not hundreds of nodes, but it makes sure that when you bring up the system, it's all documented in code. And that's one of the DevOps paradigms, even if it's a small number of machines. Yeah. Yeah, and again, I mean, it's about complexity. If the complexity is, okay, I have to add a new user or I have to change the password, then don't bother. But if it's about a whole bunch of things that you always have to do when you bring up that system or when you upgrade it, then give it a try. More questions? This one.
I have seen that the client uses root privileges. Is it required?
The Salt minion can run without root privileges, but then of course it's very limited in what it can do. That's a kind of generic problem in Linux or in all the Unixes that are not like there's an AIX that does it differently. Yeah.
So yeah, the default setup for the minion, like Joe was saying, is to run as root because then it can do what it needs to do. Salt does ship with a system called a pseudo executor. So we added this in the 2015.8 release. What the pseudo executor does allow you to do is run the minion as non-root, and then all of the execution commands which run on the minion are processed by sudo. And so then you can use sudo as your privilege gate, which means that it makes it a lot easier to be able to specify that some commands need sudo, some commands don't need sudo, and then the minion receives a localized, narrow privilege set based specifically on what you want it to do. Does that answer your question? No. Okay. Thanks.
Yeah, and of course, conceptually, we could do anything that we did with, let's say, dbus and PackageKit. It's not a limitation of Salt. It's just if you run a Salt module and it has to be to do things that only root can do, you have to find a way of making sure that it can. Yeah. So I could imagine in a future release that we would implement something similar to PackageKit, where you expose certain features to a user using dbus, for example, and then trigger it from Salt. Yeah. Just in most cases, when you talk automation, you have to lock down that part of your infrastructure anyway, because even if you're limiting users to only doing certain things, just be aware that there's always a chain. Like if you can install a package, you can do anything as long as the package is installed using RPM, and then RPM is running as root and so on. It's very easy to be in a kind of false sense of security where you think you are secure. But actually, of course, a SUSE Manager server or a Salt master, if you're root on that machine, you rule your data center, anything. Yeah, that's part of the automation paradigm, because you want to be able to change anything, to know about anything's going on. That's why you have to secure the infrastructure. That's why we are using strong encryption for all the transports. And yeah, you shouldn't be sloppy with securing that SUSE Manager server or that Salt master.
Yeah, Joe said that fantastically. And I really like the fact that he brought up that you need to be careful with security, that you aren't applying layers of security that make you feel good but don't actually help in the end. We see that's a very, very common thing that we run into, is that people don't understand that, like Joe was saying, if you're allowing somebody to install an RPM, or you're allowing somebody to shell out, or even if you feel like you're restricting other things, you're allowing somebody access to a system which is running that logically itself doesn't have security gates. So yeah, just be aware of the entire chain all the way down. Any other questions?
Nope, doesn't look like it. Okay, thank you very much, gentlemen, for your keynote, and please round of applause. So the SaltStack Summit is going to take place in Gallery. That's the other room next to the bathrooms here. And then the SUSE Lab Summit will start in here in about 15 minutes. Also, I want to thank our sponsors, Coca-Cola and Monster, so you can get those free in the back at the bar. Please do enjoy the beer garden at some point. There is Wi-Fi access out there. And the food truck is here, but it'll open at noon. Thank you.